In this lecture, we are going to see about Taylor's theorem and Maclaurin's theorem. Small variation between Taylor series and Taylor's theorem. You remember that there are two types of problems. Sometimes they ask a Taylor series problem. Sometimes they may ask a Taylor's theorem problem. Just a small variation. If you know the Taylor's theorem, you can usually get the knowledge about Taylor series. Just missing the nth term or leave the nth term and so on. It's enough in the Taylor series. Series means up to infinitive. Theorem means it has finite number of terms. For example, here theorem statement, Taylor's theorem statement. If f of x in Taylor's theorem, we considered only one function, f of x. It has a n minus 1th derivatives. First derivative, second derivative, third derivative, up to n minus 1th derivative. And their derivatives should be continuous. F dash first derivative exists and the resultant function is continuous. Similarly, second derivative exists. Their resultant value is continuous in the interval a to a plus h. Likewise, n minus 1th derivative exists and the resultant one is continuous. Second condition, f nth derivative of x exists, but this result may or may not continuous. But up to n minus 1th derivative exists, they are continuous resultant values. F nth derivative exists for every value of x in the open interval a comma a plus h. Then there exists one number theta. Theta lies between 0 comma 1 such that f of a plus h value equal to f of a plus h into f dash a plus h square by 2 factorial into f double dash x plus and so on plus h power n. In case of Taylor series, no need to write down this last factor, this term. Simply leave it and so on. But you must write down at least three or four non-zero terms. The series f of a is 0. For example, f dash a is 0, f double dash is non-zero. Don't stop up to f double dash. At least you find other two non-zero terms. In the series expansion, we need to show that at least 3 or 4 non-zero terms in the expansion. So now, in case of Taylor's theorem, we take a remainder term, nth term, because nth derivative exists. In case of Taylor series, infinite times of derivatives exist. That's why we don't take nth up to nth derivative. Infinitive, n tends to infinitive in case of Taylor series. Same formula, just leave this one, last one, and so on. For fourth, third derivative, fourth derivative, fifth derivative, plus and so on. Just you simply write down up to fifth derivative and so on. We will see later. First, you listen that. In this nth term, h power n by n, please listen, the f of a plus h into f dash a plus h square by 2 factorial into f double dash x. Sorry, not x, at a. Next term is h cube by 3 factorial into f triple dash a. And so on. F h power n minus 1 by n minus 1 factorial into f n minus 1 the derivative at a. But nth term only at the point a plus theta h. Previous terms all are at a. In the last term only at a plus theta h. This term is called remainder, Lagrange's remainder. This theorem is called Taylor's theorem with the Lagrange's remainder because nth term contains the Lagrange's error. This remainder is also called error or remainder. Different textbooks give the different names, but anyhow it is a Lagrange's remainder. So in this theorem statement, instead of a we replace with 0 and h with x. Then the resultant theorem is called Maclaurin's theorem. Putting a equal to 0 and h equal to x in the above equation means above theorem. Then the resultant equation is in the form f of 0 plus x. 0 plus x becomes 0, x. 0 plus x becomes x, f of x in the left hand side. F of a becomes f of 0 because a is replaced with 0. Similarly, x into f dash 0 plus and so on. X power n by n factorial into f nth derivative of 0 plus theta x. 0, adding 0, value does not change. Therefore, theta x. This is called Maclaurin's theorem with Lagrange's form of remainder. Okay, this is called Maclaurin's theorem with Lagrange's form of remainder. Just put a equal to 0. You remember the Taylor series theorem. In the Taylor series theorem, you replace A with 0 and H with X, we get a Maclaurin's. Most of the time, in case of Taylor series Maclaurin's theorem, most of the problems asked based on the Maclaurin's theorem. See, we will see here Lagrange's. First problem. Find the Maclaurin's theorem with the Lagrange's form of the remainder for the function f of x equal to cos x. You observe that the theorem means you must represent the nth term. If it is a series, no need to represent the nth term. Here, the solution for the first problem. Here I provide the two problems. First, I solved the first problem. The second problem is important. It is also tricky to solve. Whenever we solve the second problem, we must need some attention. Solution. What are the things we required to represent Maclaurin's Maclaurin's theorem? We required f of 0 value. At the same time, f dash 0 value, f double dash 0 value. At the same time, f nth derivative of theta x value. So find f dash x, f double dash x, f triple dash x, and so on. So general, here I am explaining what is the derivative of f of x. The derivative of f of, that means f dash x minus sin x. Derivative of sin x becomes cos x minus sin as usual. Derivative of third derivative of x, sin x, cos x always minus sin x, minus into minus plus, and so on. So now you understand that even number of times, if you differentiate two times means even number of times, we get minus cos x. If you multiply fourth derivative, if you find fourth derivative of x, sin x becomes cos x. Even means without derivative is also zero derivative. F of x means is called zero derivative. So you observe that even derivatives. 4 times derivative becomes cos x. First derivative becomes minus sin. Second derivative becomes minus cos x. So usually this value f nth derivative of x of cos x becomes cos of n pi by 2 plus x. For example, first derivative. First derivative means f dash x. F dash x value is, we know that f dash x value is minus sin x. Put n equal to 1 in this formula. This value becomes cos of 1 into pi by 2 plus x. Cos of pi by 2 plus x. Pi by 2 plus x. Pi by 2 means first quadrant. Plus x means it fall into second quadrant. Plane is divided into 4 quadrant. First quadrant, second quadrant, third quadrant, fourth quadrant. This angle is 90 degrees. Pi by 2 means 90 degrees. 90 degrees plus theta means it is falling to second quadrant. In the second quadrant, all silver teacups. Cups. Silver means sine and its inverse functions are positive. Sine only positive. Cos is negative. One more thing, here we have pi by 2 means odd number of times. 1 into pi by 2. Odd number of times. Whenever you see the odd number of times, cos becomes converted into sine. One more thing, in this value fall into the second quadrant. In the second quadrant, cos value is negative. That means minus sine x. Cos of pi by 2 plus theta equal to minus sine theta as per trigonometric function. That's why you remember this function simply. We can evaluate either even or odd, whatever it may be. So using this formula, find f of 0 value. F of x is cos x. That implies f of 0. We require f of 0. That means cos 0. Cos 0 is 1. Similarly, f dash x. F dash x value is What about f dash x? Minus sin x. That implies f dash 0 is minus sin 0. Sin 0 value always 0. F double dash x is minus cos x. That implies f double dash 0 equal to minus cos 0. Cos 0 value is 1. Minus into 1 means minus 1. And so on. This is second derivative. F triple derivative. Minus into minus plus sin x. That implies f triple derivative at 0 equal to sin 0. Sin 0 value is 0. F fourth derivative. Sin x derivative becomes cos x. That implies fourth derivative at 0. At 0 equal to cos 0. Cos 0 equal to 1. Alternative plus or minus and odd derivative value is 0. First derivative, third derivative values are zeros. And even derivatives. First even derivative, first 0 derivative 1, second derivative minus 1, fourth derivative plus 1, next sixth derivative value is minus 1, alternative plus or minus 1, and so on. One more thing, we required a nth derivative term because we want to represent in the remainder, Lagrange's remainder form. So we required f of nth form or f to n plus 1th form. F to n of x value. As per the formula, f to n of x value equal to cos of derivative. To n times derivative value equal to, if n time, this value is n into pi by 2. 2n times 2n into pi by 2 plus x. 2 get cancelled. Cos of n pi plus x. This value becomes minus 1 whole power n into minus 1 whole power n into, what about the resultant value? N pi plus, n pi means n equal to 1, it becomes pi. N equal to 2, it becomes 2 pi. N equal to 3, it becomes 3 pi. N equal to 4, 4 pi. That means pi plus means all silver teacups either fall into this quadrant or fall into first quadrant. In the first quadrant, all are positive. In the first quadrant, it is falling always even number. N is even number. N is even, for example, 2n is, for example, 2 into n equal to even number. Even number means n must be, totally resultant value is even number. N must be even number, then only this value is even. Even means it becomes positive into cos x. This is the value. F to nth derivative of x equal to minus 1 whole power n into cos x. This is the value. You remember the derivative of the function. Next one. What about n plus 1th derivative? What about n plus 1th derivative of this function? Just replace n with 2n plus 1 because we know the nth derivative of x. F of nth derivative of x equal to cos of n pi by 2 plus x. Now here instead of n we have 2n plus 1. Just replace n with 2n plus 1. Just using. Now this derivative value equal to cos of 2n plus 1 into pi by 2 plus x. This value equal to cos of n pi. Simplify this expression, pi by 2 plus x. N pi value always cos becomes cos, either plus or minus sign, don't bother. This value becomes minus 1 whole power n into cos of pi by 2 plus x. Minus 1 whole power n, pi by 2, cos pi by 2 becomes second quadrant minus sin pi by 2. That means minus 1 whole power n plus 1 into sin x. At 0, sin x value always 0. At 0, sin x value is always 0. Don't bother about it. You remember this one. Our requirement is Maclaurin's theorem, not Maclaurin's series. Maclaurin's theorem. As per Maclaurin's theorem, the formula is f of x equal to f of 0 plus x into f dash 0 plus x square by 2 factorial into f double dash 0 x cube by 3 factorial into f triple dash 0 plus x power 4 by 4 factorial into f fourth derivative of 0 plus and so on, plus as your wish you can take nth derivative because odd number of derivative, because odd number is always stop before even number even number 2n derivative is minus 1 whole power n into what is the resultant value, minus 1 whole power n into x power n by x power 2n, not n, x power 2n by, please listen, and so on. You write down not nth term, you write down 2nth term, 2n by 2n factorial, but is 2nth derivative value, 2nth derivative value is minus 1 whole power n into cos x. Cos 0 always 1, so no need to write down this one. Simply write down a function form because it is a first formula, f 2nth derivative at 0. Last term is x power 2n plus 1 by 2n plus 1 remainder term into f 2n plus 1th derivative at 0 plus theta x. That means you write down theta x. 0 plus a value becomes theta. No need to add 0 because 0 plus anything equal to same thing. This is the formula. Now substitute the values. Already we know the f of 0 value. F of 0 means cos 0, 1. X, f dash 0 means sin 0, minus sin 0, 0. X square by 2 factorial into f double dash 0 means minus cos 0. Minus cos 0 means minus 1. X cube by 3 factorial into third derivative value is 0. Fourth derivative value is plus 1. You remember alternative plus or minus 1. And so on. This term, last before term value is x power n by x power 2n, not n, 2n by 2n factorial into f 2nth derivative means minus 1 whole power n into cos 0. Cos 0 is 1. Leave it. Cos 0 value no need to write down. Next term is x power 2n plus 1 by 2n plus 1 factorial into minus 1 whole power n plus 1 into sine of theta x. That's all. Because f n 2n plus 1th derivative of x equal to minus 1 whole power n plus 1 into sine x. Therefore, here you substitute theta x. That's all. Theta x. Minus 1 whole power n plus 1 into sine theta x. Theta x. This is the value. If you have any interest, furthermore, you simplify. 1 plus odd term, all are 0. X into 0 is 0. X cube into 0 is 0. Only we left, this is even term. 0 is a even number. So it is a 0th derivative, means 1. 0 is positive. Minus, next term is minus x square by 2 factorial. Next term is plus x power 4 by 4 factorial. Next term you can guess easily, x power 6 by 6 factorial. Next term x power 8 and so on. The last remainder term is minus 1 whole power as your wish. X power 2n plus 1 by 2n plus 1 factorial into sine theta x. That's all. In case of, if they ask in the question Taylor series, that time you don't write down this term. Leave it from plus onwards, plus and so on. If they ask in the examination, that time just simply write down 1 minus x square by 2 factorial plus x power 4 by 4 factorial minus x power 6 by 6 factorial plus and so on. That's all. In case of Maclaurin series, if they ask in examination point of view. Theorem, you must remember, represent the nth term as a error term or Lagrange's remainder term. Both are same meaning. This is the first problem. Next, we will go for the next problem. See, next problem is some difficulty task. Log of 1 plus x using Maclaurin series. So that for 0 less than theta less than, you take 0 less than theta less than 1, then you show that log of 1 plus x is less than x minus x square by 2 plus x cube by 3. So that means we require at least 3 terms. Problem 2. Answer for the problem 2. Here f of x equal to log of 1 plus x. What about f dash x? What about f dash x? Derivative of log x always 1 by x. If you have a f of x, if you remember, please. If you have any confusion, don't bother about it. Please send the mail or anything, or make a message, a phone call also. D by dx of log x is 1 by f of x into derivative of f of x. This is the principle. Log of 1 plus x, derivative becomes 1 by, replace f of x with 1 by x into derivative of 1 plus x. Derivative of 1 is 0, derivative of x is 1. 0 plus 1 becomes 1. This value becomes 1. Finally, we left with 1 by 1 plus x. 1 by 1 plus x into 1 becomes 1 by 1 plus x. This is the way to find the derivative of any function. This one. Next derivative. Because in our problem, we have 3 terms, x cube, up to x cube. This is first term, 1 into x into f dash x or f dash 0, because we apply the Maclaurin series. Next term is x square by 2 factorial into f double dash x. So that's why we require this term also. This value is 1 by x power or f of x. Move the denominator to numerator and apply the derivative principle. F of x whole power n formula. F of x d by dx of f of x whole power n formula is n times of f of x whole power n minus 1 into d by dx of f of x. These are not a formulas, actually these are the theorems, but their statements are used many places. That's why we treated as a formulas. Every time it is difficult to prove the theorems. That's why we remember these statements of the theorems as a formulas for other problems, for solving other problems. F double dash of x. Using this formula, we get 1 plus x whole power minus 1. Apply this formula, minus 1 into 1 plus x whole square. Similarly, we required f triple dash of x. Similarly, we take f triple dash of x, because in the problem it appears 3/3 degree up to x cube. This value same thing, 1 plus x whole power 2 is moved to numerator, it becomes 1 plus x whole power minus 2. Apply this formula, we get minus 1 as usual, minus 2 by, this value becomes 1 plus x whole cube. Then the resultant value becomes 2 by 1 plus x whole cube. Now we're happy. We stop the process. Find f of 0 value. F of x value is log of, f of x value is this one, log of 1 plus x. F of 0 means substitute x with 0, log of 1 plus 0. That means log 1. Log 1 value always 0, whatever the base. Next, f dash 0. F dash value is 1 by 1 plus x. That means 1 by 1 plus 0 equal to 1. Similarly, f double dash 0. Minus 1 by 1 plus 0 whole square. That means minus 1 by 1 equal to 1. Minus 1, sorry. Minus 1. You take a third term as a remainder term or error term. That means theta x. f triple dash of theta x equal to 2 by 1 plus theta x whole cube. Apply the Maclaurin's theorem. Write down the Maclaurin's theorem. By Maclaurin's theorem, f of x equal to f of 0 plus x into f dash 0 x square by 2 factorial f double dash 0 plus x cube by 3 factorial into f triple dash of theta x. F of 0 means already we evaluate the f of 0 value 0 because f of x value is log of 1 plus x. Substitute x equal to 0, we get 0. X into f dash 0 value is minus 1. X square by 2 factorial into f double dash 0 value is f double dash 0 value is f dash value is plus 1. F double dash 0 value is minus 1 plus x cube by 3 factorial into f triple dash of theta x value is 2 by 1 plus theta x whole cube. Simplify this expression. First term no use, x minus x square by 2 factorial means 2. Simplify this, 2 get cancelled, we get plus x cube by 3 by 1 plus theta x whole cube. This is the expression. But we have another thing also in the same problem. Using 0 less than theta less than, Maclaurin series over. Up to Maclaurin's theorem, applying Maclaurin's theorem, we find the expression up to 3 terms. In the third term, have a error. Now using that and using this 0 less than theta less than 1, we want to show that log of 1 plus x is less than x minus x square by 2 plus x cube by 3. So give a equation number 1. Given 0 less than theta less than 1. Multiply with x because in the denominator we have theta x. So multiply with x, x is positive number. So 0 into x into 0, theta x less than 1 into x becomes 1. Multiply with x, where and x greater than 0. Because log x function work out on the positive values. That means theta x less than x. Adding 1, inequality does not change. Take a cube, cubing, squaring, any power, because they are positive numbers greater than 1, and reciprocate. This value becomes 1 plus theta x whole cube, 1 by 1 plus x whole cube. Okay, one more thing, it is better to here also see. In the inequality, we have 3 terms. Continue with the 3 terms, it is better. Up to this, okay. Adding 1. One plus 0, 1. Cubing on both sides. This value 1, 1 plus theta x whole cube. This value 1 plus x whole cube. Reciprocate, we get 1 greater than 1 by 1 plus theta x whole cube by 1 plus x whole cube. Taking these two. Substituting this value in the equation 1. Give this equation number 2. from 1 and 2. See, from 1 and 2. No, from 1 we have 1 plus, sorry. F of x value. F of x means log of 1 plus x equal to f of x equal to x minus x square by 2 plus x cube by 3 into 1 by 1 plus theta x whole cube. But this value less than 1. That means which is less than x minus x square by 2 plus x cube by 3 into 1. Because this term is less than, total value is also less than. That is log of 1 plus x less than x minus x square by 2 plus x cube by 3. This is the answer. Okay. Next topic is a Taylor series, Maclaurin series. We will see next section problems.